This is for Year 12 Specialist that comes out of the Calculus Integration Topic Test for 2021, and it's Tech Aloud question number 2. In this question here, I have intersections of circles, and I can see that the intersection point is at 0, 3 and 3, 0, and that my circle equations, if I was to solve that for y, gives me y equals plus or minus the square root of 9 minus x squared, and if I rearrange this one for y equals, I get y equals, haven't done it yet, interactive advanced solve for y, not x, end up with y equals plus or 3 plus or minus the square root of 6x minus x squared. So they've rearranged, expanded and combined terms. Okay, so if I'm looking for the definite integral that represents the area, it's going to be top curve minus bottom curve. So it's going to be, so writing the definite integral, area equals the integral from 0 to 3. Top curve is the positive square root of this one. So the square root of 9 minus x squared minus, and the bottom curve is the negative square root of this one. So 3 minus the square root of 6x minus x squared dx. That's going to give me my method mark for the definite integral that represents the area. Top curve is the positive square root. Bottom curve is the negative square root, because we're looking for this part of the semicircle for that circle. State the exact area. Okay, so over here, the integral from 0 to 3. Top curve is the positive square root. Minus, and since I've got two things happening here, I'm going to open up a bracket to put the negative square root in. Now, I deliberately solved for y on the calculator so that I was able to drag and drop these here. And there's my answer, 9 pi on 2 minus 9 square units. Okay, to the second part of the question, the region is rotated around the y-axis to form a solid. So write a definite integral that represents the solid, state the volume. So the volume is going to be the integral. If we're going around the y-axis, it's going to be y1 to y2, which is 0 to 3, top curve squared minus bottom curve squared times pi dy. So I'm looking for v equals pi from 0 to 3 of x squared of the top curve minus x squared of the bottom curve dy. So if I'm rotating around, this is still my top curve and this is now my bottom curve, still with respect to the y-axis. So looking at x squared is going to be 9 minus y squared. So I'm looking for pi from 0 to 3 of 9 minus y squared minus, and I'm looking for x squared. So if I take this, so if I come and I solve this for x, and I'm wanting the negative square root, so I'm wanting this one here. So I'm wanting 3 minus the square root of 6y minus y squared. So there is my answer for the definite integral. And to find the volume, so what I'm going to do is I'm going to then we're going to have nine minus y squared. So the square root of 9 minus y squared. And this one here will be that squared dy, and that gives me an answer of 27 pi on 2 minus 27, and of course I didn't put the pi in, and that gives me an answer, well, get rid of the pi from there, put the pi in that position, and that will give me a pi squared pi cubic units.